Hello students, this is Dr. Ben, and this is an example problem from the middle part of chapter 4 that has to do with the topics of force and motion. So we have the situation where a person is pushing a car in a horizontal direction. We've got a lot of information about the forces that act on the car, and also about the motion. And essentially we want to decide whether this person is pushing hard enough in order for the car to make it through a patch of road where there's sand and a very large coefficient of friction. So I'm going to approach this problem by considering the forces first, and that analysis will help us find the acceleration of the car when it's in the section of the road where there's the sand. And then, by considering the motion part of the problem second, we can decide whether that acceleration results in a final position, and whether that's equal to the 10 meters or not that was given in the problem. So if the person is pushing hard enough, then the car will make it through the 10 meters before its speed gets to 0. But if they're not pushing hard enough, then it won't make it through the 10-meter section. Alright, so to do the forces first, we need to draw a force diagram for this object. So we'll do this on a horizontal axis. So we'll let the box represent the car and its center of mass. The person exerts a horizontal force on the car, so that's going to point to the right. Pushing force. We'll have a weight force and a normal force acting on the car, and then frictional force will point to the left if the velocity of the car is to the right. But in this particular problem, because the car is slowing down as it's being pushed, the acceleration is to the left. So I'm going to need a coordinate system in order to analyze the forces. So I'll use x to the right and y up. And now we can go ahead and make a table of what we know, at least about the forces part of the problem. So we'll do that up here. So we know the mass of the car is 1,000 kilograms. And you know that the pushing force, P, is given to be 600 newtons. Alright, the coefficient of kinetic friction is equal to 0.7. And we're supposed to assume that G is equal to 10 meters per second squared. Alright, so since we have the coefficient of friction and not the frictional force, that means that we're going to have to analyze the vertical part of this force diagram in order to find the normal force. So in the y direction, there is no acceleration. So in the vertical direction, the net force is equal to 0 because the car is at rest. So from the force diagram, we would write down that N minus mg equals 0, and therefore the normal force would equal the weight. Now we're going to need the frictional force for the x part of the problem, and we might as well figure that out at the moment. The frictional force would be equal to the coefficient of friction multiplied by the normal force. So in our situation, that would be the coefficient of friction multiplied by the weight. So now we can go ahead and consider what's happening in the horizontal direction. So now the net force in the x direction is not going to be 0. It's going to add up to a number that points left because this car is slowing down as it goes through the sand pit. So let's go ahead and write down in the x direction that A sub x is equal to the net force in the x direction divided by the mass. And so we see from the force diagram that that is the pushing force minus the frictional force divided by the mass. And since we have the expression for the frictional force from above, we can write this out algebraically as P minus mu K mg divided by the mass of the car. So now we can go and look back at our table of the known values. The pushing force was 600 newtons minus the coefficient of friction was 0.70. The mass of the car is 1,000, and the acceleration due to gravity is 10, and then that gets divided by 1,000. Alright, so the second term is 1,000 times 10, which is 10,000, times 0.7, so that's 7,000 negative, plus 600, so that gives us negative 6,400, and then divided by the 1,000 below, so we're going to get 600 minus 7,000, all divided by 1,000. So that's negative 6,400 divided by 1,000. So therefore, the acceleration in the x direction is equal to negative 6.4 meters per second squared. So that is the acceleration that the car has caused by the pushing force and the friction. And now we'll go ahead and solve the motion part of the problem and see how far the car travels as it decelerates by this amount. Alright, so now that we've figured out the acceleration of the car as it's traveling through the sand pit, it was equal to minus 6.4 meters per second squared. Now we can consider the motion part of the problem in considering the slowing down of the car as it's traveling through. So we want to draw a pictorial representation for this problem along the horizontal direction, and we'll pick 2 points of interest: the beginning of the sand pit and the end of the sand pit. So we'll have point labeled number 1 and point labeled number 2, along with the variables x1, v1, and t1, and x2 and v2 and t2. And the acceleration is to the left in this picture because the car is slowing down. And we could go ahead and write down our given information on this pictorial representation. So x1 is going to be equal to 0. v1 is given to be 10 meters per second. We can start the experiment at time 0. The sand pit has a length of 10 meters, and v2 is going to be equal to 0 if it doesn't make it through, but it could be a positive number if it does make it through. And the value of t2 we don't know, but we don't necessarily even need to find. Alright, so since we have information about the position, the velocity, and the acceleration, it makes sense to use the third equation on the list that has the squares. So that would be that v2 squared equals v1 squared plus 2 times the acceleration times x2 minus x1. And so what I want to do is to actually find the value of x2 for v2 being equal to 0. So I'm going to use that as my condition for deciding whether the car makes it through the sand pit. So if the value of x2 is less than the 10 meters, then it didn't make it through. But if it's more than the 10 meters, then it did. So we can solve this numerically, and we've got all the numbers that we need. So v2 is equal to 0 squared is equal to v1 squared, 10 squared, plus 2 times acceleration that was minus 6.4 multiplied by the variable that we're going to leave here, which is going to be the x2. Alright, so if I take the 10 squared to the other side, I get negative 100 is equal to negative 12.8 times x2, so therefore x2 equals negative 100 divided by negative 12.8. And that number is definitely less than 10 meters. 100 divided by 12.8 is actually 7.8 meters. So it appears like this car does not make it through the sand pit. The pushing force was not enough to give it the acceleration that was needed to make it through this sand pit. It actually came to rest at 7.8 meters from the origin. Alright, so that's another example of a force in motion problem. This time we had to solve the forces part of the problem first, so we could make a conjecture about the motion part.